So for this one, we want to evaluate these derivatives. And one thing we might notice is whether we have a definite or an indefinite integral. The difference between those are whether or not it has bounds. So if I look at A, I see that it is an indefinite integral. And anytime we have an indefinite integral, our solution will have a plus c. So let's go ahead and find an antiderivative for this function. So I know that the derivative of sine is cosine, so an antiderivative for cosine is sine. And I know that for the function x squared, an antiderivative for that will be x cubed over 3. And then I need a plus c. So that accounts for any variation. So basically the answer here is a family of functions that look like sine x minus x cubed over 3 plus any constant will have this function as its derivative. So for the next one, I have an indefinite integral, or I have a definite integral. So the answer to this one won't have a plus c. I'm going to use the fundamental theorem of calculus, part 1, to find the solution for this. So first I need an antiderivative for 4 over x. So it's going to be 4 natural log x, and I'm going to evaluate that from 1 to 2. And so by the fundamental theorem of calculus part 1, I need to do 4 natural log of the top bound, which is 2, minus 4 natural log of the bottom bound, which is 1. And so the natural log of 1 is 0. And if I think of 4 natural log of 2, I can either keep that as 4 natural log of 2, or I can write that as the natural log of 2 to the 4th. So either of those answers is fine. And so we don't have a plus c on that one because it was a definite integral. So for the next one, I think with these square roots, the easiest thing to do is to start out by just rewriting it. So I'm not going to take an integral yet, so I'm going to leave the integral symbol. I'm just going to write that as t to the 1/2 minus 1 dt. All right, now I'm ready to find an antiderivative. So to the 1/2, I'm going to add 1 to the power, so it'll be t to the 3/2, and I'm going to divide by my new power, so 2/3. An antiderivative of 1 is t, and note again that this is an indefinite integral. So I need a plus c at the end. So for this one, I want to evaluate a of -3. So in my function a of x, the x becomes the top bound. So this is going to be the integral from -5 to -3 of f of t dt. And there's my function f right here. So if I want to integrate from -5 to -3, it's going to just be the area of this triangle right here. And so the area of that triangle will be 1/2 base times height. So 1/2 times the base, which is 2, times the height, which is 3. So the area of that triangle is 3. Next it says, for what values of x on the interval from -5 to 5 does a of t equal 0? So a of t is an accumulation function, which gives me the area underneath the graph of f, starting at -5. So if I look at what's happening here, I'm accumulating positive area until I get to -3, and then I start accumulating negative area. So when I get to -1, I've accumulated the same amount of positive area and negative area, so that the integral there will be 0. So, so the answer here is x equal -1, because the integral from -5 to -1 of f of t dt is equal to 0. Because I have the same amount of positive area as I do negative area. But then as x goes on, it continues to collect negative area, and there's never a point where it equals out the same amount of positive and negative area. So that's the only one. On C, it says find a value of x where a of x has a local maximum and justify your response. So since I know from the fundamental theorem of calculus part 2, so I can say that FTC2 says that a prime of x is equal to f of x. And so if I want to find where a of x has a local maximum, I first want to look, where does a prime of x equal 0? And that's true for x equal -3 and 4. And so if I look at those critical points at -3 and at 4, I want to see what is a prime doing on either side. So here, a prime, which is the same as f, is positive to the left of -3. And it's negative between -3 and 4, because it's below the x-axis. And then after 4, a prime, which is the same thing as f, is positive again. And so if I think, what does that mean about a? So a is increasing, then a is decreasing, and then a is increasing again. So if I want to find where it has a maximum, that's going to happen at x equal -3. So a of x has a max at x equal -3, and this is by the first derivative test. Okay, the next one, I want to define capital F of x to be the integral from 2 to x of f of t dt. And it wants me to find capital F of 0. So capital F of 0 is going to be the integral from 2 to 0 of f of t dt. One thing you might notice is that my bounds are in decreasing order, so I can switch my bounds by making this negative. So now I want to compute the integral from 0 to 2 of f of t dt. So if I look at that, the integral from 0 to 2 will just be the area of this rectangle. So what is the area of that rectangle? First of all, notice that it's a negative area because it's below the x-axis. And so this is going to be negative of, so it's 2 times -3. So it's going to be negative of -6. So it'll be positive 6. So for the last one, I have a graph of g. So let's think about what these 4 things are. So g of 4 minus g of 2 over 2. Well, let's see. What's g of 4? G of 4 is 3. G of 2 is 1. So this is 4 minus 1 over 2. Oh, whoops. G of 4 is 3, not 4. G of 4 is 3. Sorry. 3 minus 1 over 2. Okay, and so what is that? That's 2 over 2, which is 1. And it's also the slope of the secant line, if I think about it that way. Okay, and what is g prime of 2? Well, g prime of 2 is this slope. So I don't really need to compute that slope necessarily, but I can note that it's less than that red slope. It's less steep, and they're both positive. So this is less than 1. The next thing I might note is if I'm looking at this integral from 2 to 4, so that would be this area underneath this curve. And what I might notice is like, that's 1, that's 1, that's 1. If I look at the area underneath this curve, I'm going to say it's greater than 3. Because those green boxes represent 3 units, and we've got a little bit more than 3. Then this one is asking for the limit as x goes to negative infinity of g of x. So as I'm going to negative infinity, what's happening to my function value? Well, it's getting closer and closer to the y value of 0. So let's just say, it says assume the end behavior is as indicated. So it seems like as x goes to negative infinity, that function is getting closer and closer to the y value 0. Okay, so now we can put them in order because we have a feel for how big these things are. So the smallest looks like 4. And the largest looks like this integral on 3. So to receive credit, you must convey your rationale for your selections. Okay. Well, I guess that's good enough rationale. So this is an area under the curve. This represents a slope of the secant line. And this one represents the slope of a tangent line. So there's my rationale.